This video is about numerical measures of variability. Our objectives are to talk about range, variability, and standard deviation. The important terminology for this section deals with measures of variability or spread, and these help us to visualize the shape of the data and reveal the extreme values or measurements that may exist in the data. The range of a quantitative data set is equal to the largest measurement minus the smallest measurement. Deviation is the distance and direction between each measurement and the mean. Sample variance for a set of n measurements is equal to the sum of the squared deviations from the mean. And we have two forms of the formula for sample variance given here. We will be using this second form, and I will show you how to easily set up a table, and then we can substitute our sums into the formula. The sample standard deviation is simply the square root of the sample variance. Now we have different symbols dealing with sample variance and standard deviation. Notice S squared is for sample variance, while sigma squared is representing a population variance. S is the sample standard deviation, while sigma is the population standard deviation. Today we will deal with a sample. For our first example, we're going to calculate the range, variance, and standard deviation for the following sample. The range is found by arranging the measurements in ascending order, then subtract the smallest measurement from the largest measurement. So I've ordered our measurements 37, 38, 40, 41, and 42. Therefore, the largest measurement of 42 minus the smallest measurement of 37 is equal to 5. Our range of the data is 5. Next, we will arrange these values into a table. Each measurement is considered to be my x value. So I've kept them in order from smallest to largest, 37 to 42. And in the second column, I'm squaring the measurement. So 37 squared is where 1369 comes from. So I'm taking 37 and squaring that value, and that's what equals 1,369. So I will do that for each measurement. Finally, 42 squared, the result is 1,764. You'll notice now in the table, I've got the sum of my x's. I'm simply adding 37, 39, 40, 41, and 42, and that sum is 199. Starting with 199, I will square that, and that is my squared sum of 39,601. My other column is x squared. I will sum all of the x squared values, and that is called the sum of x squared. That total is 7,935. Now that I have completed the table, I can substitute these values into our formula for sample variance. Remember, S squared represents sample variance. So our first number, 7,935, comes from the sum of my x squared values minus the squared sum divided by the sample size. So I have 5 values, or 5 measurements, so the n I'm substituting is equal to 5. Next, I'm dividing by my sample size minus 1, so that would be 5 minus 1, leaving me 4. To work through the numerator of our formula, I'm taking 7,935 minus 39,601 divided by 5, which I've converted into decimal form. With the subtraction, I end up with 14.8 divided by 4 is equal to 3.7. So 3.7 is the sample variance for the data set. Now that we know the sample variance, we simply take the square root of 3.7, which equals about 1.92. If you want to round that to tenths, you would have about 1.9. Example B is a new data set, 100, 4, 7, 96, 80, 3, 1, 10, and 2. So to find the range, we would place our measurements from the smallest to the largest, and therefore the largest of 100 minus 1 makes 99 for the range. So the range of the data set is 99. Our table, I'm placing all of my x values in ascending order, 1 through the 100. And the second column in the data set, remember I'm taking my x value, I'm squaring that to equal 1. And I will do the same for every measurement. Finally, 100 squared would make the 10,000. I have all of my sums computed, so I'm simply adding 1, 2, 3, and so on down through 100, and I have 303 for that sum of the x values. Once we have the sum of x values, square 303. That is called the squared sum. That makes 91,809. In my x squared column, I'm adding 149 all the way down through 10,000, and that sum of the x squared values is 25,795. I can then substitute these sums into the formula for sample variance. I begin with my sum of the x squared values, which is 25,795, and I'm subtracting squared sum divided by n. In this case, we have 9 measurements. All of that is divided by n minus 1, which would be 9 minus 1, ultimately 8. So I'm starting with my fraction, and if you prefer to convert that to decimal form, or you may end up with an integer, we have 10,201. Is that divided evenly? In our numerator, 25,795, subtract 10,201 gives us 15,594. Divide that by 8. Our final answer for sample variance is 1,949.25. Again, depending on where you would like to round this, you may call that 1,949.3 if you would like to round to tenths. The standard deviation then is simply taking your variance and finding the square root. So that is found right here, and that's about 44.15. Depending on how you want to round that, if you go to tenths, 44.2. And that is our standard deviation.